This video is for lesson 6.6 scatter plots. A scatter plot is a graph of a set of data pairs x, y. And scatter plots are not necessarily perfectly straight lines, hence the name scatter plot. All of the examples we had done in this chapter previously were perfectly linear relationships. A scatter plot doesn't necessarily have that exact perfectly linear relationship, but there is sometimes a correlation between the data that shows a general trend of the graph. So if the correlation of the data is a positive correlation, that means as the x values increase, the y values also increase. If the general correlation of the graph is negative, that means that as the x values increase, the y values decrease. And finally, sometimes there is no correlation between the values in the x and the y, and that there's just no relationship between them whatsoever. So let's take a look at what these might look like if we had an actual scatter plot graph. So this first example shows a positive correlation. The second one shows a negative correlation. And the last one shows no correlation whatsoever. So you can see even in the first two, it's not a perfectly straight line, but you can see a general trend of the points going in a positive direction. And for the second one, they're generally decreasing, going in a negative direction. But the last one, the points are all over the graph. There's no trend of one or the other, positive or negative. When we draw a scatter plot, we typically also draw a trend line or a line of best fit that tries to most accurately illustrate the relationship between the two variables. So we can tell that it's a positive or negative correlation, but we sometimes want to use an actual equation to represent the line. Even if it's not a perfectly linear relationship, we can create an equation that would fit the general trend of the graph. So we're going to do this example, and you can fill this out in your notes, and I'm going to walk you through how would you do this if you were doing this by hand. Now, when we do this by hand, you might have a slightly different answer than the person next to you, but that just means that you picked two different points than they picked. And as long as our answers are close to each other, and the key here is finding a slope that is close to the general trend of the line, it's okay if you don't get the exact same answer as the person next to you. I will also show you how to do this on Desmos, and the Desmos will calculate the best line of fit, but when we're doing it by hand, we are leaving it up to a slight human error for each picking some different points. So just for the sake of doing this example together, the two points that I picked for this line of best fit to go through are, and we're just going to call this 125, and then I also picked 200 or 300 and about 35. Now these aren't perfect because this one is not exactly at 35, but just for the sake of estimating our line of best fit, I'm going to use those points. So now if I connect those dots, the goal here is that when you connect your dots that you pick, the 2 points, you want to have about half of the points above the line and about half of the points below the line. You also don't want to pick 2 points that make the line way steeper than the majority of the points. Like I would not want to pick this point and this point because that would be a really, really steep line, and that doesn't represent the general trend of the graph. So you want to pick 2 points that kind of roughly estimate the direction of the points. Then you're going to first find the slope. So we'll do 35 minus 25 over 300 minus 100. So that'll give us 10 over 200. And again, this, when we do it by hand, is an estimate. 1/20th if I simplify it. And then, like I said, if you had, let's say this was a test or a homework assignment and you picked two slightly different points, let's say you picked this one and this one, you might have a slightly steeper line than mine, but it shouldn't be drastically different, the slope, than mine. So the key is that you have a slope that's reasonable and pretty close to, everyone has a pretty similar slope, even if it's not identical. And then to write an equation, you just write it in point slope by taking the slope and picking one of your 2 points. And again, that's going to depend on what points you picked in your original line. So depending on which points you picked, obviously you'll have different options, but this would be an equation for the line of best fit in this example here. If I were to simplify this into slope-intercept form, you would just distribute your 1/20th. So you get 1/20th x minus 100 divided by 20 is 5. And then you'll add 25 to both sides. So you end up getting a rough y-intercept of 20, which if you look at the graph based on the line I drew, that makes sense. It's not perfect, slightly below 20, but that's because the 2 points that I picked aren't perfectly accurate. Okay, so again, when we're doing these by hand, you'll see it's not going to be exactly the same answer as maybe on an answer key, but as long as you are reasonably close to the slope, that is okay. All right, so I want you to give this one a try, and I'm going to put 4 answer choices for you to pick which one is closest to the answer that you got. I'm going to pick some that are not reasonable, and 1 would be the most reasonable answer. So I want you to pick which one is the most reasonable line of best fit equation for this graph. Okay, so one other thing we can calculate with a scatter plot is what's called the correlation coefficient. So we can talk about positive, negative, or no correlation. We can also talk about how closely those scatter plots resemble a perfectly linear relationship or a straight line. So the closer the dots are together, the closer it resembles a linear relationship, and the more spread out they are, the farther away from a linear relationship they are. And that's what the correlation coefficient tells you. The correlation coefficient is going to be somewhere between -1 and 1. And what that tells you is the closer it is to -1 or +1, it'll tell you that it is almost a perfect straight line. So that would be almost a perfect linear relationship. So here we have if r is equal to -1, then that means your points are very close to being a negative sloping line. If it is close to +1, that means your points are very close to being on a positive sloping line. And if it is anywhere between -1 and 0, and 0 and 1, the closer it is to 0, then that means the farther spread out the points are all over the graph. 0 would be no correlation at all, where the points are completely scattered everywhere. And the closer and closer the points get to resembling a straight line, the closer and closer those correlation coefficients get to 1 or -1. So just as a few examples to kind of help you understand what I'm talking about, this says for each scatter graph, tell whether the correlation coefficient is closest to -1, -0.5, 0, 0.5, or 1. So I want you to just try each of these. The first one would be closest to 0.5. So you can see it's positive. So you can see a general positive trend, but the points are not very close together. So it's not going to be 0 because there is a positive trend of the points, but it's not going to be 1 either because the points are spread out. So this would be closest to positive 0.5. In the second graph, this would be closer to -1 because you can see how much closer the points are together. They are closer to resembling a straight line than in the first example. So this is going to be closer to -1 than to 0. And in this third example, there's no correlation at all, so that would be a correlation coefficient of 0. There's no positive or negative correlation here. All right, let's give this one a try as well. A set of data has a correlation coefficient of R. For which value of R would the data points lie closest to a line? Okay, so I'm going to show you how to do this using Desmos, and let me go to Desmos to show you how to follow these directions. So these directions I will come back to, but I will go through them as well step by step in Desmos. I will also post a screenshot of these directions so you don't have to write down every single step, because I know in your notes you have just the graphing calculator directions, and we're just going to use Desmos. So I will screenshot this and post it on Google Classroom too, so you don't have to write every single one of these steps down. So we're going to use these two examples, and rather than us graphing a scatter plot and finding 2 points and going through that whole process that I showed you earlier, I'm going to show you how you can use Desmos to calculate the line of best fit and find the correlation coefficient all at once. So let me go to Desmos. And the first thing you're going to do when you're in Desmos is you're going to click the plus sign in this upper left corner. We're just going to desmos.com. This is not a pre-made activity that I made. You're just going to go to desmos.com, as I just did, and click Graphing Calculator. So the first thing you're going to do is click the plus sign in the upper left-hand corner, and you're going to select Table. And then you're going to enter the data in the table of the problem that we're working on. So the first one in your notes is this average male lung power. And if I type in all of the X values, those are the values on the top row, which represents the breaths per minute. And then on the bottom row, the Y values is the heart rate. So you're going to just enter each of these in. Now, if you look at the graph to the right, nothing shows up, and that's just because these values are way bigger than what the scale is right now. So you can zoom out until you can see the dots. Now you can tell just by the picture that this is pretty close to being a straight line. So you can kind of predict already that our correlation coefficient is going to be pretty darn close to a positive 1. But what we're going to do is we're going to ask the computer to calculate not only our correlation coefficient, but also our line of best fit. So what we're going to do is we're going to now click the plus sign one more time. This time we're going to, well, 2 more times, but we're going to click expression, and you're going to type in Y and then the number 1, and then you're going to use this shift and then the squiggly key, and it's in the top left corner of your keyboard below the escape key. So that's the squiggly approximate symbol. And then you're going to type mx1 plus b. Now, as soon as you do that, before even hitting enter or anything else, you see that this information pops up below, and it actually draws your line of best fit for you. And if you look at the measurements in the underneath what we just typed in, you can see the statistics. So we actually did not talk about what R squared equals. That's a different calculation that we're not going to learn about. We want to look at R, which is your correlation coefficient. So it's 0.99. That means these points are pretty much as close as you can get to a straight line without them being a straight line. And then under where it says parameters, it gives you M, which is your slope, and B, which is your y-intercept. And that is all you need to write your line of best fit equation. So notice you really didn't do anything, any calculations. The computer did it all for you. All you did was enter the data information in the table. So once you enter that into the table and you type in what I typed in here, y1 is approximately mx1 plus b, that information automatically pops up there for you. Now I do have one other step on there that says to click and add expression and then to type in the y equals mx plus b formula. So basically typing in the slope 2.63816 x plus b, which is 70.514. But like I showed you already, the line came up before I even typed that in, so you really don't have to do that. But if I get rid of that, the line of best fit is still there. But that is how you would write your equation. So let me go back to here just so I can show you, just make sure we're following along. The equation for the line of best fit for this one would be y equals 2.63816x plus 70.5, sorry, that's a little sloppy, 14. Now, this, since the computer did it, everyone would get the exact same answer every single time, and then our correlation coefficient is 0.99. So the only time we get slightly different answers is when we do them by hand. Okay, so I'm going to have you try this second example here. This is in your notes, so I'm going to pause the video or go back to the directions for the Desmos so you can go to desmos.com, follow along these steps right here, and find the equation for the line of best fit for that second table, the wind chill temperature for 15 miles an hour winds.